Check. Checkaroo. All right, I require some kind of confirmation of my existence. Am I here? Is this real? Oh, Kim Barron says video and audio. All right, let's get cracking then. Here we go. Okay. Kimmy Chemtrails. Get at me when you find actual space footage, not CGI and cartoons. 2026 and still trying to make people believe cartoons are real. Amazing. So, when we put images into our shows, right, into Space Bites, into the question shows, we use a mix of real footage, real images taken by telescopes, and artist illustrations. And the reason is because there are things in the universe that we have never taken images directly up close with a kind of resolution that would ooh and ah. So for a scientist, they're very happy when you get the spectra from some galaxy or star or planet or whatever, that you get this very complicated looking graph that shows you the presence of various chemicals. And yet that's the chemical fingerprint of that thing. You can learn so much more than anything from the spectra of what you've taken with your telescope, but it is not pretty to look at. Or a radio image that is showing you the magnetic field polarity of some region around a galaxy. It is not pretty to look at. And so unless you know what it is that you're looking at and you really appreciate the angular resolution of the telescope image. So like just in general, astronomers are different from the people who are trying to convey and communicate the information that the astronomers are discovering. That when a black hole is tearing apart a star, we know this is happening. We can sense from all of the light that's coming at us what actual event is going on here. But how this looks in the science paper is, again, very boring. It has to be your imagination that takes you to this idea of what this thing looks like. And so, imagine if you were watching a sci-fi documentary and they stop to say, and this is the point where the black hole consumes the star, and there's just a graph. And the graph has like a little bit of a line where there's a peak in brightness where the star was consumed. And then the narrator says, imagine in your mind this rapidly spinning black hole that's distorting space-time around it. And this star is straying too close and gets pulled into this tidal stream that whips around and it gets intensely bright as the star is getting disrupted, and it causes this bright explosion. And you're just like staring at this little graph, right? So instead, people use the same technology that people use for movies to try to imagine in the most realistic manner possible what that thing is going to look like. It's the same thing if you're watching some historical documentary about the Roman Empire, and they're going to show people wearing Roman outfits, walking around with their swords on the battlefield. And it's not actually them. It's an illustration. It is a recreation of this thing that is happening. So we put illustration beside anything that is not real, or that anything that has been created. And then the stuff that we don't put illustration beside, you can feel confident and safe that it's an actual picture of the thing that we are describing. But, a lot of the times people, and I'm assuming you're one of these people, don't kind of know what is the difference between what is actual pictures of space, which can be really amazing. Some of the pictures from telescopes, nebulae that are happening, actual pictures of spacecraft. We've seen pictures of landers on Mars taken by orbiters orbiting around on Mars. It's incredible. So, you just have to sort of gain more experience in what the capabilities are of the different telescopes, different instruments, different spacecraft, what is real and what is an artist's illustration. I think, I don't think people do as good enough a job of making it really clear what is an illustration, then they should. But we try to make it very clear. It says illustration on it. And so that's our way of saying this is someone attempting to interpret what this incredible event might look like if you were close. Again, you watch a documentary about dinosaurs walking around. Do you write a grumpy email to the producers of the thing? Like, I want to see just bones of dinosaurs. I want to see just like a collection of bones in a box. That's all I want to see. And the rest of it is your imagination, trying to imagine these dinosaurs walking around. No, you want to see them. And that they may not be completely accurate, but it's great to kind of give you something to try and connect to. Okay. So this is, of course, our weekly question show. We try to lead with a zinger that then will get people's attention, and then they're going to want to watch the rest of this live stream. But those of you who are here now, you know how this works. For the next 2 hours, we are going to explore your questions about space and astronomy, and I am going to be your guide to this incredible cosmos. So go ahead and put any questions that you might have into the YouTube comments. I've got a little database thing here that will allow me to catch the questions and be able to answer them. But like, here's how this works is that, if you write something into the YouTube comments and into the live chat and has a question mark in it, then that will be filtered over. If you use the who, what, where, when, why, and how, then that will also get caught and show up in this system. So just try to ask your question in the form of a question is the most likely way for me to be able to see it. So a couple of caveats, of course. I am a journalist, not a scientist. And so, you may want to ask my opinion about some scientific matter. Which theory do I like better? And I am agnostic. I just don't care. I am interested in the discovery and the hunt, in the mystery, in the sort of scientific consensus, but I don't have a dog in this fight. The next thing is that I try to give emphasis to the people who've never had a question answered before, and I can see how many times you've all had your questions answered, how many times they've been featured. So just like, be brave. If you're sitting here and you're just watching, or you've got someone, if your kid is watching this with you, ask them to ask me a question, and I like your chances of it getting answered. Especially answers from kids. They're brutal, the questions from kids. The toughest questions you ever get. And then the last thing is just, I may not know the answer to your question. It may require too much math. It may be something that we've answered very recently. So just, don't take it personally if I haven't answered your question. We get about 3 times as many questions as I have time to answer. And so I will do my best, but sometimes my best just isn't good enough. All right, let's get going. In Armstrong, I was wondering if I could get a little clarity on the process. It happens the instant 2 black holes merge. Does that cancel out the spin rate of both black holes? So when 2 black holes merge, you don't cancel out the spin rate. You just essentially average out the spin rate. And so if the 2 black holes are spinning in the same direction, then the combined object is going to be spinning with the average rotation of the 2 black holes that came together. And in fact, this process is what sets a solar system spinning in the first place, that you've got this giant cloud of gas and every particle that's in the cloud has its own momentum. And that as these particles are bumping into each other and they're starting to glom onto larger things and they're starting to concentrate at the core of this gas cloud, then it starts to kind of shrink down and it starts to spin faster and faster and faster. And, the classic analogy is the skater pulling in their arms. They spin faster and faster as they sort of make their axis of rotation smaller. And the same thing is happening to a solar system. And so it is spinning up, flattening out, and it is, the direction, the orientation is just the average momentum of all of the particles that made it up. And so whenever you see a black hole, then its rotation and orientation is just made up of the average momentum of all of the things that came together to make the black hole. CeeLo 87, can a white dwarf collect enough material to restart fusion, or would the atoms just stack up on the edge? So there are plenty of examples of white dwarfs that are in a binary system where they are being orbited by some other main sequence star. And if the white dwarf and the star are close enough, then the white dwarf can steal material from its partner. And this material sort of builds up on the exterior of the white dwarf until it reaches some critical level. And then you get this thermonuclear flash off of the surface of the white dwarf, which clears up all of the material, and then the process starts again. And this is known as a nova. And so this is an event that happens. We know of many recurring novas across the Milky Way, where every few decades they have built up enough of this material that it's enough for it to ignite fusion on the surface of the white dwarf, and then it flashes off, and then it starts back again. So that's like one example of, I think, what you're talking about. And the problem is just that you get, the amount of material that is required just burns off in this bright flash. You don't get it restarting the fusion because, the core of the white dwarf is the leftover remnant, is essentially the core of the star. So you think about, say, a star like the sun. It has hydrogen and helium in its core. And so it's mashing the hydrogen into helium with fusion, releasing energy, and using up that hydrogen fuel at the core. And the amount that is able to do that is dependent on the entire mass of the star. And then the star runs out of helium in the core, and so it switches, the star runs out of hydrogen in the core, and so it switches to helium. And so now it is fusing helium into other elements up the periodic table of elements. And it goes through oxygen, and I think it gets to carbon, and then that's where a star like the sun stops. But the core accounts for about 50% of the mass of the sun. And so then the sun goes through its red giant phase. So then the sun goes through its red giant phase, sort of throws off all of its outer layers, and then eventually all that's left is the core. And so, theoretically, if you could put 2 more stars worth of hydrogen around the star, then you would be able to reignite the core, and it would be able to start proceeding again. But the problem is that you're not going to get that much material. You're just going to get small amounts at a time. It's going to build up on the surface of the white dwarf, and it's going to explode. And the other thing is that there is a type of this process which creates a type 1a supernova. And so when a white dwarf has accumulated 1.4 times the mass of the sun, it explodes as a supernova. And the fine tune of this is still a little unknown, but it has to do probably with the speed. So if the material is coming in slowly enough, then it can build up on the surface of the white dwarf, flashes off, and it just kind of clears the plate for next time. But if it's coming in, like a lot of it is accumulating on the surface of the white dwarf faster than it can flash this stuff off, then you can theoretically get one of these type 1a supernova. And in that case, the thing just explodes. So no, becoming a white dwarf is a one-way process for stars. Owen Bowen, when is the first live Vera Rubin show? So I've been just sort of scheming and playing around with the data, and we just released our interview about the data pipelines for Vera Rubin, and this was like a way for people who have some kind of programming skill to actually try to integrate, develop into this pipeline and try to make something of your own that allows you to try to show off the data in a way that you think is really cool. And I've got a bunch of ideas. And so I think what I'll probably do is do like a live session, I'll live stream it, and we'll build some stuff with Claude Code and try to integrate with various tools that I'm aware of for doing visualization. So we could make something, I was thinking like we could have a constellation that shows where Vera Rubin is taking its pictures right now in the constellation, or we could have a sort of an all-sky version of the universe and then show where various objects have flashed off, like supernova, things like that. That'd be kind of cool. So I've got a bunch of ideas, and now the tools are just so easy. And I talked about it, like you can go to the Antares data broker through NORLab and just get access to this stuff and make things. So it's a pretty amazing, like literally now anybody, like if you just have an idea, spin up Cloud Code, ask it to help you out with this, and you'll get to a place where you've made something that's pretty cool. And this was never available. Like in the olden days, you would have to be a programmer and you would have to make this stuff yourself. You'd have to know how to interact with the APIs of all of this. And now you can just ask Claude to do it for you. Orbits 4. Have you done interviews on solar panel production via lunar materials, knowing SpaceX's focus on the moon and data centers in space? I saw an interview from Alien Space. Yeah, I have done interviews about this. I've done a bunch. They're a little older, so maybe about 4 or 5 years. In fact, maybe even longer. Time has no meaning at this point for me. But there's this technology for building solar panels called perovskite. So, the main type of solar cells that you're all familiar with are, is it silicon carbide? I forget the silicon gallium. Anyway, so the main kind of solar cells, so the main kind of solar panels, they're like chips. They're like circuits. And they work pretty well, but they're fairly expensive, although the prices have come down so much now to make. But they're still more expensive. There's this kind of cheaper technology called perovskite. The problem with perovskite is that it is very reactive to oxygen. And so, oxygen in the atmosphere will destroy these solar cells. But they will probably be a great methodology for doing them outside in space or on the surface of the moon. And so the interview that I did was this idea of like having a rover that crawls along the surface of the moon, scoops up lunar regolith, and then just leaves a tail behind it of perovskite solar cells. And there was another interview that I did fairly recently, maybe 2 years ago, about sort of self-replicating robot factories on the moon that, you could probably, with simpler technology, like not the kind of 3 nanometer chipsets that we're dealing with today, but with simpler, more rudimentary chips, you could probably make a lunar factory that can make another copy of itself on the moon just out of the local material, the local resources. So you can, like, you wouldn't have to make the quality of the solar panels that we have here on Earth with enormous manufacturing, huge scale that happens in China to make these things, but you could make less efficient but quick and dirty things on the moon just out of the local material. And we've done a ton of coverage on Universe Today about this as well. So this is definitely an idea that people are thinking about. King Tad, Fraser, if you were a scientist and not a journalist, what would you want to focus your research on? What burning question would you focus your career on? I don't know. Part of the problem is just like the way my brain is wired, that I don't have the kind of attention span for doing the kind of long, detailed, in-depth research that might be required to make serious progress in one field. I would just be too interested in tons of other stuff. And so I would be much more of a dilettante. I might get my degree in one field, but I would be sort of picking up knowledge and information from other fields as well. But I also really kind of believe that when you are, like, you get your bachelor's degree, you understand the fundamentals of science in your field. When you get your master's degree, you're starting to understand the nuanced aspects of your field. And it's not until you get your PhD that you are making actual progress in your field. Like the person who has gotten their PhD knows more about one specific little piece of that field than anybody else in their field. That's sort of what getting your PhD is that you are making a new scientific contribution. You're discovering something. And it's only then that you really understand the landscape of what's out there to be discovered and what the outstanding challenges are and what work is to be done. And so, I think that I don't know very much at this point. And so I wouldn't know what would be a good problem to tackle and what would be a bad problem to tackle. Like, obviously, there are questions about is there life in the universe? Where did the universe come from? What is dark matter? What is dark energy? But are they tractable problems? Are they problems you could make progress on in a scientist's career lifetime? I don't know. So there hasn't been a moment where I've decided that I need to spin up a bunch of books, write my paper, and send it off like a crank to physicists, hoping that they're going to take me seriously. So I've never gone beyond. Like, it's weird. I don't even have hunches anymore. Like, I think when I knew less, I hunched more. And you'll see me do this in real time in a specific situation where I'll be asking an astronomer a question and I will be sort of trying to have a hunch and try to express that hunch in real time. And they'll be like, yeah, we thought of that. And, here's why that's not a great idea. Or, no one's really looked into that. Oh, okay. Maybe that would be interesting. So yeah, that part of my brain is gone. Like I have, as I have learned both the kind of the state of the reality and how complicated it is, and I've gained more respect for the abilities of actual scientists who are doing this work, my desire to contribute has gone to zero, right? Where I am, my purpose is to communicate. And that is the thing that I try to think about a lot. How do I communicate this better? How do I do a better job of walking this fine balance between being scientifically accurate and telling interesting stories that people want to learn more about? And I think I'm too far removed now from having hunches about space. Swat Ozdermercy. What is that one propulsion technology you hope to see become a reality in your lifetime? The one you think will finally make interstellar travel possible? Well, from what we know, there's really only two methods of propulsion that would make interstellar travel possible. One is a laser sail, some kind of way of accelerating a spacecraft with a laser that is off of the spacecraft. And so you don't need to carry your propellant. You just get this gigantic boost. That sounds very dangerous. There's no brakes. It sounds scary. The other one is antimatter. And that if you could actually build an antimatter rocket, then the amount of delta V, the amount of change of velocity you could get, is feasible for you to be able to accelerate, fly to a nearby star system, decelerate, and be able to explore it. So really, the only game in town for us is antimatter. And so somebody needs to develop antimatter production at scale, antimatter storage, magnetic confinement, and some kind of some antimatter rocket that will actually use the antimatter for that propulsion. It's good timing because we're going to watch Hail Mary this week probably. And they sort of cover this kind of idea that they extract all of humanity's energy into trying to create enough fuel to send a spacecraft to another star system. And that's the kind of scale of energy production that we would need to set our our sort of society to. You know, people always ask, like, what's the point of a Dyson sphere? Well, maybe one of the points of a Dyson sphere is that you have antimatter factories all around your star, that you're trying to turn all of the energy coming out of the star into antimatter so that you can then build spacecraft that can go to other star systems. So, like, that might be the scale that this takes. And skeptic, is there a planet with a moon with a moon with a moon system anyway? So I mean, you went one level deep into that. That's Inception. So, you know, obviously planets can have moons, and that if a moon can have a moon, theoretically, although we don't know of any examples of this. I mean, obviously, the moon has an artificial satellite around it. You know, we have a bunch of spacecraft that are in orbit around the moon. So that is theoretically possible. The only place in the solar system where that would be possible would be Neptune. So Neptune could have a large moon that is far enough away from Neptune that then that moon could have a moon and it would be stable. And the technical term for this is a moon. So that Neptune would have moons. Now, what you're describing, a moon with a moon with a moon, would be a moon. And although it is, I guess, theoretically possible to have a moon going around a moon, going around a moon, going around a planet, going around a star, I haven't heard of anybody make the case that this is something that we should expect to see in the cosmos. Blade Solar, do you think mining at the asteroid belt will ever be reality? And what is H3, the element that is found on the moon? So the first question, do we think asteroid mining will ever be a reality? So, you know, I think when a lot of people hear the idea of mining asteroids, they think that we're going to mine the asteroids and then bring the material back home to Earth. But that will probably never be economically feasible. That the cost of sending a spacecraft to an asteroid to try and extract the resources and bring them back home is just more expensive than just digging a hole in the ground. That, yes, there is a higher concentration of gold and palladium and platinum and all of these things on asteroids, but the costs of going and getting them are so high that it's never going to make more sense. Where it does make sense is when you use that stuff in space. So, you know, we will eventually have factories in space. We will have colonies on the moon and Mars. And to send more material to them, instead of trying to carry that stuff out of the enormous gravity well from Earth, you could send that stuff from an asteroid. And so the amount of energy that's required to send it over there would be much lower. And so helium-3, let me just get the yeah. Just want to make sure I've got the chemistry of it. 2 protons, 1 neutron. Okay, all right. So for the second part of your question, what is H3? That's helium-3. And so normally helium is 1 proton and 1 neutron. And helium-3 is 2 protons and 1 neutron. No, wait, sorry. I got it wrong. Sorry. Helium-4 is the common one with 2 protons and 2 neutrons. Okay, let me do that again. All right. So the H3, that's helium-3. And the standard helium that you put into helium balloons, the stuff that we find here on Earth, is helium-4, which is 2 protons and 2 neutrons. But helium-3 is 2 protons and 1 neutron. And it's incredibly rare. We have tiny little amounts of it mixed in with regular helium here on Earth, but you would have to extract enormous amounts of helium to try and get even just the tiniest amounts of it. But helium-3 is produced by the sun. So that part of the solar wind contains this helium-3, and it impacts the surface of the moon. And so people have proposed that you could go and dig up the regolith on the surface of the moon, to get at the helium-3. So why would you want helium-3? So for fusion reactors, theoretically, helium-3 would allow you to produce a fusion reaction that gives off less radioactive particles while you're running your fusion reaction. So, with the standard fusion reaction, you're going to be putting out a lot of particles that, potentially are going to seep into the sort of the containment chamber, and you're going to have to sort of be far away from your fusion reactor. But if you want to make a very small reactor, or you want something that's on your spaceship, then helium-3 might be a good way to go. Now, the problem, of course, is here we are in the year 2026, and no sustained fusion reaction has been developed. Fusion is always, 25, 30 years off. People are working on it in a bunch of different ways, but we'd have to go through standard kind of deuterium fusion, tritium fusion, and then maybe later on someone can figure out helium-3 fusion. And then if that's the case, then maybe there's a resource that's on the moon that is more valuable. Then if that's the case, then maybe there is a resource on the moon that is valuable enough for us to mine it and bring it home to Earth. But even that seems, that there's still helium-3 can be found in other pockets here on Earth. Thomas Mirror audio not. A moon's moon is called a moon's moon is called a moon. OMFG astronomy, grow up. Yeah. I mean, there is no official name for this because it's never been discovered, and so people call them moonlets, submoons, but the one that I like is moon. Just deal with it. Just go to your happy place. Just endure. You can do it. Testing. Do you think that we should establish Aldrin cyclers between the Earth and the moon before we make a base and a factory on the moon? Between the Earth and the moon, I'm not sure. So the idea of an Aldrin cycler, proposed by Buzz Aldrin, is that you would have a spacecraft that is traveling between the Earth and Mars. And so it would be on this regular trip going from the Earth to Mars and back again. And it would be a fairly big spacecraft. It would be kitted out with all of the luxuries that you would require to make this long journey. And so then if you wanted to make this journey, this spacecraft would never need to slow down. It would have to make slight course adjustments with its fuel, but in general, it would just keep making the cycle from Earth to Mars and Earth to Mars and back again. And so you can sort of leave all this mass just going. And then if you just want to you can resupply it. You can send astronauts to it. When the cycler gets close to Mars, then the astronauts get off and they land on Mars. And then other astronauts get off of Mars and land on the cycler. And then they come home to Earth. And it's a great idea. It's a big chunk of infrastructure, but it would allow you to have more luxury and comfort and protection and safety and supplies for the mission. And in fact, if you think about The Martian, the movie The Martian, they had the spacecraft that was going in orbit between the Earth and Mars, and then was going to come back to Earth. And they actually did go in orbit around. Never mind. We'll drop that part off. And so you're proposing, should we build a cycler that goes from Earth to the moon? And, theoretically, sure, you could build a spacecraft that is doing this big, long orbit between the Earth and the moon. And so you would launch astronauts up, they would dock with the cycler, and then they would be carried up to the moon, and then they get off there, and you'd refuel it and so on. And, I'm sure something like that was thought of when people were considering the Deep Space Gateway, the Lunar Gateway, that now the Lunar Gateway is going to be in this rectilinear halo orbit that's going to essentially be doing this figure eight around the Earth Moon L1 Lagrange point. But you could have something that's just in orbit around the Earth and the moon, and you can use it to jump on and jump off. And it would be like a half space station, half ferry boat taking you to and from the moon. But there's like a lot of moving parts. Like, that's overly simplified. Like, you have to reboost it, you have to maintain it, You have to time things very carefully because it's a moving vehicle. So it comes with headaches of its own, but I'm sure people have done the math and thought about it, especially Buzz Aldrin. Kirk Wagner, when docking to an Aldrin cycler, aren't you just using as much energy fuel as you would if you just flew directly? Yes, but you can be in this sort of larger, safer, more established vehicle, right? Like there's the value of the mass, and you're just essentially just resupplying this vehicle. And so there's you don't need to carry all of the mass that's going to protect you in space. So there's it's very, very quick ship that gets you up to the cycler, and then you stay on board the cycler. Don't do that. Melon Torja, will you make all Lagrange point questions video just like the black hole questions one? So I did a search last week, as some people were recommending that, and I came up with about 80 episodes, 80 questions that tackle Lagrange point questions. So yeah, they're out there. We need more people to watch the black hole one because it actually, didn't get a lot of views. And so we need to know that this technology of us doing these supercuts of the questions is the thing that people want to see. We definitely, some people thought it was great and some people listened to it, and some people found the Easter eggs that we had snuck into it throughout the episodes. We know people listened to it, which was great, or watched it. Now, who could watch it? No, you probably listened to it. You probably fell asleep to it, and then you woke up in the middle of the night and happened to notice the Easter egg. But it was a lot of work. Anton, think about how much time it would take for him to just pull together all the separate bits and pieces from all those videos to just assemble that into a 10-hour video, and then all the fine tuning that he had to do and so on. Yeah, it was a lot of work. It might be a one-off. It might be a thing we'll do again. I think if I was going to do whatever would be the next one, it would probably be astrobiology. It would probably be life in space, right? Because then we would get all the Fermi paradox questions, all the Drake equation, all of the biosignatures, astrobiology, great filter, and then a lot of other questions about life. So, or like one on exoplanets, that'd be cool. But, I think we need people to watch them because it's a monster, right? And we totally get that. Like, it was not meant to be watched and enjoyed. It was meant to provide you a valuable service of going to sleep. But if you enjoyed it, then great. I'm glad. We so busy wondering if we could, we never stopped to ask if we should. Blade Solar, are you a fan of the show For All Mankind on Apple? I'm so pumped it's returning this month. Absolutely. I have put For All Mankind into my top 10 best science fiction television shows ever. I don't know which slot it took, but it's up there. If you haven't watched it, For All Mankind is about what would happen if the space race continued. If the Soviets got to the moon first, and that just kind of kicked off this ongoing race between the Soviets and the Americans for the high ground of space. And so they build bases on the moon, and they race to send the first humans to Mars, and they build a base on Mars. And it's just a great alternate history, counterfactual on what would happen. And so the fourth season is going to be coming out in just a couple of weeks, and I'm really looking forward to it. I found the third season was a little weaker than the first two. The first two were so good, especially like the first one was just so great. So, but yeah, if you haven't watched For All Mankind, now's your chance. Catch up and then watch it. Kim Barron, what about breaking it into smaller chunks? Yeah, like what if we just gathered a bunch of like random questions and just packaged them together into a, I don't know, like a questions show? That'd be a pretty cool idea. Google, where's the recommended shows wiki? All right, so I keep talking about my top. I have a list of my top 100 movies, and I have a list of all of my favorite television shows, but it's just on my computer. I'm looking at it right now. So I have to publish this. And thank you for the reminder. Stanton, so the plan is the moon first, then Mars. Uh, yeah, whose plan? Which plan? Which iteration of which plan? So right now, the plan for NASA is, Artemis 2 is going to launch probably within a couple of weeks, we hope. Artemis 3 will be a test of docking in space around Earth. Artemis 4 will bring humans to the moon. And by the mid Artemis 6s and 7s, we'll probably see the beginnings of a base on the moon. Or we will see a complete retreat from the moon because it was incredibly expensive and nobody wants to spend that kind of money on lunar exploration. So that's from the Americans. But once there is an established base on the moon, then a lot of the technology that would be used on a mission to Mars will be tested out. And so you can imagine then in the 2030s, 2040s, people would start to test out ideas for sending people to Mars. But it's funny when you think about it. Like if we go all the way back to maybe the late 20 teens, early 2020s, if you told me that the first human will set foot on Mars in like 2035, I'd be like, yeah, that sounds about right. But here we are. That's just 9 years away. I don't think the first human is going to set foot on Mars. Like someone is going to return to the moon by 2030, maybe 2029 if the Americans are able to beat the Chinese to the moon. Even though they've already been to the moon. So 23. So that means like we probably won't see missions to Mars into the 2040s. Like it's just reality, right? At this point, like all of that technology has to be built. Now, Elon Musk had been planning, if you kind of go back to the original plans, if you go like all the way back to the announcement of the interplanetary transport ship, they were expecting that they were going to send their first spacecraft in 2018. And then that number got shifted. You saw 2020 that spacecraft would go to Mars and help scout out and try to test out technologies for building fuel. And then you'd have the first humans going in 2022. Well, here we are, 2026, and the Starship has not like fully flown in its final configuration yet. And we are not looking at any missions to Mars now, probably 2028. They could theoretically have the technology to send a spaceship to Mars, but now they're not going to. They're going to be going to the moon. So at this point, I think, SpaceX is going to contribute a lander to the Artemis mission, and that's a big priority, and that's a big deadline that they've got to be able to hit. They've got a little more breathing room now that NASA has pushed back Artemis 4, or pushed back the human landing to Artemis 4. You're probably looking at 2028, 2029. But yeah, now the Chinese, they're planning on having humans set foot on Mars. The Chinese are planning to have humans set foot on the moon 2030, but they're already building the technology, the infrastructure to send humans to Mars. after that. So they've already tested out all of their sample return missions on the moon, and they've already tested out sending a spacecraft to Mars with the Tianwen rover and lander. And so the next big mission that's coming from China is going to be in 2028. They're going to send a return mission to Mars, which is a thing that nobody's ever done before, right? Nobody's ever returned samples from Mars. And yet returning a sample from Mars is roughly equivalent to returning humans from Mars. And so they will be testing out this technology. And if they are able to pull it off, I wouldn't be surprised if we get an announcement from the Chinese that they're going to attempt a mission to Mars in the late 2030s, sort of on their schedule. So, yeah, the moon first, then Mars. And that's the right plan. That's the right decision. The moon is close. The moon is relatively easy. You can learn mistakes quickly. You can send people home if there's a medical emergency. You can send resupply if there's some problem. You can rescue. Once you go to Mars, all of that stuff is off the table. They're on their own. And so it makes sense. We just do not have the wisdom to travel in deep space yet. Even though Mars would be really cool, we're not there yet. But I know Bob Zubrin believes that we are there. Melantorja is looking back how things worked out in the world. Is the Expanse's Epstein drive poorly named? Yes. Melinda Green, why is the U.S. even racing China to the moon? Didn't we beat them in the 1960s? Well, of course, right? The first person to set foot on the moon was Neil Armstrong, and that record will stand. First person in space was Yuri Gagarin, right? First person to orbit the Earth. So that record will never be taken away. And whoever, do you remember the name of the first Chinese astronaut? I don't. Oh my God. As soon as I see it, Liu, man. Let me look that up. Yang Liwei. Okay. Yeah. Yang Liwei was the first. Yang Liwei was the first Chinese astronaut, and so that's an accomplishment that at this point when he first flew in 2003, right? The space shuttle had been flying. That the U.S. and other countries had put hundreds of astronauts into space, and so you just don't remember. And so when the first Chinese astronaut sets foot on the moon, we will celebrate and remember their name, but they didn't beat the Americans to the moon. The Americans beat them by 50 years. So there isn't a race. And yet, I think that, that this is a narrative that China wants people to see, that they are a true scientific nation, that they are not just the place where you get your cheap toys made and drones, that they are a nation that is capable of doing great things. And one of those great things is going to be sending humans to the moon and bringing them safely home. So they already have people on their own Chinese space station. But then that means that the prize of having the first person to set foot on Mars is still up for grabs. We don't know who the first human is going to be. And I think the Chinese are absolutely in the running for being able to send someone to be the first person to set foot on Mars. Obviously Elon Musk talks a big game, but let's see those rockets fly. Get going. You've got about a decade to get someone to Mars and safely home before the Chinese will probably try and pull it off. But in my preference, they would be collaborations, right? That any base on the moon, there should be a new version of the International Space Station. It should be a collaboration, that the Chinese and the Americans should be working together, that there should be a collaborative mission that lands on the moon and has Chinese astronauts and Americans or some other country set foot at the same time. That'd be great. And that the base is staffed by an international collaboration. Collaborations make things better. And same thing with the trip to Mars. Ion Drive. Test question. How much farther would a trebuchet throw something on the moon compared to being on Earth? Well, the force of gravity on the surface of the moon is 1/6 what it is on Earth. And so the trebuchet would be able to fire the object 6 times as far. Wayner 77able. What part will the Artemis program play in colonizing the moon? What is the plan for the entire program? Yeah, so things get vague. Let me just see what the current plan for the Artemis is after Artemis 4. Because so I don't know if we, okay, all right. So Artemis 5, second lunar landing. Artemis 6, 2031 was to work on the lunar gateway. Artemis 7 would be to deliver the lunar cruiser. I think that's the Toyota lunar cruiser. Artemis 8 in 2033 would deliver the foundational surface habit. So a base around Artemis 8. Okay, all right. So at this point, like we know fairly certainly what, at this point we know with a lot of certainty what the next couple of Artemis missions are going to be. So Artemis 3, that's going to be the one that has a docking in Earth orbit. Artemis 4 is going to be that first landing on the moon. Artemis 5 will probably be another lunar landing. Now, after that, the Artemis missions, some of them are going to be used to build the lunar gateway. So it all depends on whether or not the lunar gateway will actually be built. So if not, you will get the delivery of the lunar cruiser, which is going to be a Toyota built sort of fancy lunar rover, something that's pressurized that the astronauts can be inside for a long time. And then, you know, we're talking like 2031 at this point. So by 2033, you're probably going to get the beginnings of the construction of the lunar base. And so that would be the beginning of a lunar base from NASA. But, and at that point, like beyond 2033, 2035, we will probably just have a continuous habitation of a base on the moon, that you will walk outside, look up into the sky, look at the moon and say, there are people on the moon right now, in the same way that you can watch as the International Space Station flies overhead and say, there are people in space. There have been people continuously on that station since the year 2000, like for over 25 years. There's just been people in space at all times. And we'll be able to do the same thing in sort of the same way. Think there are people in Antarctica right now, right? All the time. But there are some problems, which is that the underlying expense of building the Space Launch System at $4+ billion per launch is just not sustainable. It's like, it's just, there's no budget to do this at the kind of cadence that is needed to be able to build a long-term presence on the moon. So, you know, we're looking at alternative launch systems. You know, you're seeing SpaceX build Starship, and in theory, that could deliver payloads to the moon for a fraction of the price of the Space Launch System. You've got the New Glenn that could deliver payloads for lower cost. And there's even, you know, you could do things with Falcon Heavy. So when you think about how much difficulty it has taken to even get the Artemis mission to the place we are right now today, right? Like maybe Artemis 2 is going to launch in a couple of weeks. That would be great. And have some people do a flyby around the moon. And with the sort of attempts by the White House administration to cancel a lot of the funding for some of the stuff to go along with the moon landings, like the lunar gateway, it's just like, it just doesn't feel like there's any chance that what the final reality looks like has anything in, you know, any similarities to the plan. The plan is just, you know, is not guaranteed. There's not funding in place. There is not support from the government to carry out the plan. The hardware is not complete yet. So I think you can imagine a whole bunch of different future timelines. One future timeline, the Chinese land on the moon, and that makes the US very excited, and they invest a lot more money into building up their own infrastructure, and you do get that base. Now, the possibility is the Chinese build their base on the moon, and then they realize that it's too expensive, and so they abandon the idea as well. And then nobody just goes to the moon for a while. Maybe everyone looks to Mars, or maybe just none of it happens. Maybe there's just, because there is no profit, there's no value, there's nothing to be gained from sending humans to places like the moon and Mars. The only thing that to be gained is bragging rights and just a demonstration of the technology that it's the next place for us to go. Like, don't get me wrong, I would love to see boots on the ground on Mars. And I think that you don't have to justify it for anything other than because we did it, because it was hard, right? You go back to the JFK quote, right? Like, we do these things not because they're easy, but because they're hard. And having a person set foot on Mars would call on the best of us, would require the greatest engineering challenge, would require a persistent vision from multiple administrations to work together in a worldwide collaboration to be able to accomplish this incredible feat. It would show humanity what we are capable of when we pull together to accomplish something that is greater than ourselves, that will show us that we could fight, we could squabble over scarce resources, or we can begin this process of becoming a true solar system spanning civilization where the issues that we face in the today are just forgotten because they're laughably small and ridiculous at the time, like children having a tantrum because they didn't get an ice cream cone, right? That this is what we can do, and I think that's the only reason that we should do it. We should go to Mars because it's hard, and bring people back safely because human lives matter. So yeah, and that's it. So let's get on it. Darthex, is a space station cheaper if communists do it? I think the budget of China is about $6 billion for their annual space exploration budget. I don't know if it's going to change for their lunar budget, but it's about a third of the budget of the United States, of NASA. But they don't accomplish as many things as NASA does, NASA has a bunch of missions in the works, has the human program, has their space station. So, I would say they definitely, in this case, China, has a ton of engineers, ton of scientists. They pay them less than what they're paid in the US. So they're able to get more done, but at a lower budget. But not get more done than, I think the Americans NASA still has more hardware that is being produced at the same time than really any other nation. All the other nations combined. Sid Vicious, can a moon not be tidally locked to a planet and have a moon with a day-night like Yavin 4? Well, actually, so if the moon is in orbit around a gas giant, then the moon will be tidally locked to the gas giant, but its day-night cycle will match the orbital period around the planet. So it's not about how quickly the thing is rotating. And so, for example, like the moon is in orbit around the Earth. It is tidally locked to the Earth, and its day length is 29.5 days. So it takes 29.5 days to orbit around the Earth once. And so it goes through its day-night cycle once. And so if you had a planet that was in orbit around a gas giant and it was, not orbiting, or maybe it was orbiting closely and had a magnetosphere to protect it from the trapped radiation, and was doing it every couple of days, well, then you would have days and nights that are a couple of days long, which would be totally fine. So there's plenty of ways that you could have moons be habitable around gas giants in other star systems. And that's one of the reasons why people are so excited about the search for exomoons, that it might be that those are going to be the places that we're going to find potential biosignatures, because the planet is easy to find. And then you can tease out the existence of the moon around the planet. Domingo Flav, do you think we'd be able to catch a picture of Artemis 2 around the moon, or 2024 YR4 with our smart telescopes? So the Artemis around the moon, no. The biggest telescopes on Earth, the 8.5 meter, the 10 meter telescopes, can resolve objects around the moon at about 150 meters across. So you cannot see things that are small. What is 50 meters? Anyway, you wouldn't be able to see it. The Orion capsule is too small for us to be able to see with the biggest telescopes on Earth. So of course we can't see it with tiny smart scopes. Now you might see, you would be able to detect, say, when the Artemis 2 mission or the Artemis 3 mission, well, you would be able to detect when the Artemis 2 mission has launched and is still close enough to the Earth and on its way for a translunar injection. If you're on the right part of the Earth, you would be able to detect it. And when Artemis 3 does this docking maneuver in orbit around the Earth, then it will be very bright, and you would be able to watch it going overhead. And you would even be able to see like the two spacecraft that are following each other, like two stars following each other in the sky. And then as the stars got closer and closer together, eventually they would dock. That would be pretty cool. Wire 4, it's not going to be very big. It's going to be like maybe 50 meters across. And so it could theoretically come within, a few 100,000 kilometers of the Earth, but it would be really tricky for you to see. No, the one you want to be able to see is Apophis, which is 2029. You'll be able to see that with your eyes. Like, you won't even need a telescope. There will be this star that moves across the sky, and that was the asteroid that almost hit the Earth. Charon 156, is there any plan to give the moon its own GPS setup or a moon positioning system? Yeah, absolutely. It's called LunaNet. And this is an international collaboration between NASA and the European Space Agency and JAXA and other people. And they're working on essentially a coordinated moon time, which would then be, if you were, like time on the moon is kind of complicated because the moon doesn't stay in any one time zone. The moon moves through the time zones. And not only that, but the gravity on the moon is different than the gravity on the Earth. Clocks tick more slowly on Earth because we have a deeper gravity well. And so clocks on Earth and clocks on the moon would start to go out of sync. And so you need to account for that. And then, as you said, you would need to have some kind of global positioning system. You need to have satellites that are in orbit around the moon that are able to send positioning information to rovers and stuff down on the surface of the moon. Now, it's not urgent yet, but as there's more infrastructure on the moon, then eventually there will be missions that their only job is to help with navigation down on the surface of the moon. And then the same thing will happen to Mars. Like, eventually there will be a global positioning system on Mars to help navigate on the surface of Mars and tell time. Because again, Mars time is going to have a different time than moon time and Earth time. Smoke. With all that atmosphere on Venus, does it get proper dark on the night side, or does it get only murky? No, it gets proper dark on Venus. So a day on Venus is very, very long. Like 225 days long. So Venus turns very, very slowly. And Venus is actually flipped upside down. So it's turning backwards from the other planets in the solar system. And so, during the daytime, like we saw the images coming from the Venera program, which the Soviets sent these landers down to the surface of Venus. And so in the daytime, they were able to see features around on the surface of Venus, even though it was, would have been very dim because you're down through all of that murk. And so not a lot of light is going to make its way down to the bottom of that really thick atmosphere. It's an atmosphere that is as thick as the ocean 1 kilometer deep. Like it's a very thick atmosphere. But once it turns into night, then there's nothing that's going to cause that atmosphere to glow. So it's just going to get dark and hot, and the temperature stays the same. Like it doesn't cool down at night on Venus. The temperature just continues to be the same, like 460 Celsius everywhere on the planet, whether you're at the poles, whether you're near the equator, doesn't matter whether it's day, whether it's night, it's that same temperature. Robert, have you seen any UAP? Oh, what did I see? I feel like it was about 6 months ago. I saw 2 satellites that were kind of in formation. So they were sort of a chunk of the sky and they were moving together. But like pretty far apart. Like they were maybe 5 degrees, 10 degrees apart. So they weren't right next to each other. And it might have been that was, say, the Chinese space station with a resupply craft going to it, or some other spacecraft that was chasing down another spacecraft or something like that. It was very weird to me that they were moving together. And so they were unidentified in that I hadn't identified exactly what satellite it was. They were aerial, though really they were in space. Although, they could have been airplanes, but I don't think so. They were satellites, and they were a phenomenon. So yes, I saw, or a UFO, an unidentified flying object. I definitely saw an object that was flying that I was unable to identify. But I don't think it was aliens. I just couldn't identify it, and I didn't feel like going and looking it up and trying to figure out what it was. So I'm just going to leave it as I didn't know what it was, but it was weird. I was surprised to see 2 satellites moving in formation, and I didn't care. Fred Schroeder, do you have your tickets to the Hail Mary project yet? Based on the trailers, what do you think? So I don't have my tickets yet, and I won't need to get tickets. I live in this small town on Vancouver Island in Canada. We have 1 movie theater. They're going to play it, but I'll watch it in the matinee in the middle of the day. There won't be a lot of people there. It'll be quiet, and we'll watch the movie. And I am really looking forward to it. I actually got invited to go and see the premiere in Vancouver, which is the big city nearby us. But it's just like it's a ferry ride, and I have to stay in a hotel and then another ferry ride. Like I'd like to see it, and I'd love to sort of experience all of the promotion for the movie, but that's just like so much time and money, so I'm not going to do that. But Hail Mary is a terrific book if you haven't read it. And if you enjoyed The Martian and you would probably love the book as well. And this looks like they're doing just a fantastic job of telling the story of Project Hail Mary. So every part of this looks great. I'm really stoked, and the initial reviews sound like it's good too. So it sounds like it's going to get onto my top 100 sci-fi movies list, maybe even make its way into the top 10. I'm looking forward to it. Well, in Georgia, what cool interviews are coming out that we should all look forward to? Let me look at my calendar. I think we've got. No, there's a bunch that you haven't seen yet. They're still in editing. So, and I've forgotten what those are now. Um, I only see the names, so I forget what these are about. So I've got 5 interviews that I have to do on Thursday and Friday this week. And then I've got no interviews next week. No, 1 interview next week. Let me see. Let me pick one here. Corian Bakerman's. What's this one? So this one is about so remember the story we did in Space Bites about the tardigrades and how they had a hard time living in Martian regolith. So we're doing an interview about that. I've got Harrison Agrusa. This is about the Phobos. About rubble pile asteroids and tidal disruption and the fate of Phobos. So it's kind of about how Phobos will get torn apart and fall into Mars. Was this interesting to you? I don't know. Ian Chow, what was his one? Something about Vera Rubin. Oh yeah. So Ian is working on using Vera Rubin as an early warning system for asteroids hitting the Earth. And so we'll be talking about how quickly Vera Rubin can find asteroids that are about to strike into the Earth. Matthew McQuinn. So that's about the cosmic positioning system. So that's using, I think, pulsars. So this is a NIAC project. So I'm still waiting for NIAC to actually release their phase 1 awards, but the people who have been awarded NIAC grants are starting to post their preprints, and so I've been sort of finding them through the grapevine. And so this is a NIAC grant, solar system scale, very large baseline to improve cosmological distance measurement. So they want to build like an event horizon telescope that will be the size of the solar system that will allow them to then have a gigantic baseline to image the universe, which sounds awesome. And then the last one is Amy Haft. Which one's that? Electrostatic tractors, right? Okay, so there's this idea for cleaning up space junk where so instead of like trying to actually grapple and grab a piece of piece of space junk, you use a tractor beam essentially. You electrostatically charge a piece of space junk and then cause it to re-enter the Earth's atmosphere more quickly. And so this is a technology I've been sort of keeping my eye on, and most of the development has been coming out of Russia, but someone in the US is working on this, so I'm going to be talking about them. So there you go. That's just this week. So there's a lot of good interviews coming. Paige Potter, do you think space journalism should ever lean more into wonder and storytelling rather than strict explanation? I mean, like, I think that there's plenty of people that do the wonder and storytelling. I mean, that's the Carl Sagan route. And if you go and watch The Cosmos, even though with Neil deGrasse Tyson, it's a lot of wonder and storytelling. And I've got some ideas for wonder and storytelling for some videos that I want to do. But it's requires more clock cycles, requires more brain power, right? Like to go and take a thing that you can explain, and then you need to sort of move it into this other phase where you're kind of dreamily describing it in these kind of cosmic terms. It doesn't come naturally to me. And so if I wanted to sort of approach things in that way, I would need to write. And I don't write anymore. I just talk. I just talk off the top of my head. So if I had more time, I'd write a more dreamy and wonder and storytelling style video. There's a lot of journalists that I really admire, and like science journalists, Ed Young. Oh man, there's there's like a bunch, and people in sort of more like long form technology reporting, things like that, where they sort of weave in the storytelling and it's more behind the scenes and they're on location and all that kind of stuff. And I'd love to be able to do that kind of journalism, but I don't have time for that. I have to turn things around very quickly. So it's like if I had more time, I would write a longer, more evocative piece. And it's just, we have limited resources here at the universe today. We do what we can with what we have. And yet there's lots of really great journalisms out there and a lot of great space journalism as well. But I don't think there'll ever be another Carl Sagan, right? Like Carl Sagan was Carl Sagan and he told stories in the way that he did. And I don't think that, like anyone, like maybe Brian Cox is kind of close, right? He's pretty great. He's pretty dreamy. Maybe David Kipping is kind of close. He has a sort of sense of wonder and uses a lot of that same kind of evocative language, but it's not me. I'm a lot more just the facts. Ion Drive, any comments on Isaac Arthur? I like, is it some scandal that I should be aware of? Isaac Arthur's great. We've done a lot of collaborations. I think he has been kind of trapped in doing stories about futurism, right? Like terraforming this and terraforming that. And so his audience really wants him to tackle that kind of futurism. And at the same time, he has just covered so much of just like all of the techno space, all of the possible futures that humanity could experience, that it's, I can see that for him, it's got to be tough to sort of find parts of the stories, ideas that he hasn't covered. But maybe he's got an unlimited number of ideas, like whatever. He's been producing videos every week for, I don't know, a decade now. It's incredible. For me, it's I don't have to come up with the ideas, right? Like I just get to watch and see what the scientists are discovering, see what papers people are proposing, wait for various events to happen, and then I get to cover them. I get to investigate them. I get to be curious about these things. And so I don't have any idea what's going to happen. Often the way this works is I'm browsing through all of the journal papers that have come out today. And then I see a couple of papers that I think are interesting, and I reach out to the scientists and say, "Hey, can I interview you?" Like that's the cycle, right? And they say yes, and then we turn it into an interview, and then it gets added to my understanding of the cosmos, and that's very cool and very exciting. But I can't imagine how hard it would be to try and come up with like, what if humans lived around black holes? What if we lived in space stations? What would the future of medicine be? So yeah. But Isaac Arthur's great. Dougal, what would you say is the biggest benefit you've had with virtual meetings with every new patron? So this is a thing that I do. And it's funny because it still shocks and surprises people that I do this, which is that whenever people sign up to become a patron, I reach out to do an interview with them. And it's like an actual video interview. So it kind of feels exactly like this, except I'm talking back to you specifically. We are having a conversation. And the joke that I always make is that, after this interview is over, if you're going to be talking to your television from here on out, you've gone crazy. But in this moment, you're not crazy. And it is very, very valuable to me as a creator. So there's a couple of reasons why I do this. The first one is that creating material content on the internet is a kind of mildly punishing experience. that, and I'm sure if you like went and looked through the comments just in this video, like there's lots of stuff, lots of great conversation, and then there's a couple of assholes, right? And they're just kind of saying things that are kind of negative, and you just, and yet our human brains will remember the trolls and forget all of the nice things. And so it is this kind of hard on your brain. It's hard on your psyche to create content on the internet because it's just so reactionary and people are so mean. So when you actually talk to a fan of your work, or you talk to someone who actually watches your content, it's amazing because they have like actual useful, solid advice, but they also just make you feel grateful to be producing this content for people. That these are the kind of people, and that they've been watching all along, and maybe they've never said anything, but they appreciated it and they enjoyed it. And that just feels good. And that it wipes out the negative experiences that you have with just the general populace on the internet, the trolls, the karma people, the people who are, shills for various ideologies, right? So that's the first thing. Like a KGB Russian troll farm isn't going to sign up to my Patreon and join me for a conversation, right? They're just going to snipe at me from afar. So that's the first reason. The second reason is like it's genuine, actual feedback. That if we're doing things wrong, if we're making some mistake, or if there's things we can do that would improve, then that's something that I'm going to hear directly from the people who actually know the content, right? Not the people who haven't watched the videos. I don't care what the people think who don't watch my videos, right? And are trolling or attempting to troll. They can just get bent. Who cares? But the people who actually watch the stuff and have feedback, then it can be very nuanced and very useful and very actionable. So like this search engine that we built for all of the question shows, I got enough feedback from people saying, sure would be great if there's a way we could search through all of your past question shows. Okay. All right. We'll do it. So that's kind of the next thing. And then it's just like, I love being able to give people this random surprise, right? A thing that they would never expect. Like, oh, wait, I get to talk to you, right? That's great. And it's very fun for me. So, and it doesn't take up a lot of my time. Like I do probably 5 or 6 interviews a week, and they're about 15 minutes. Maybe only a quarter of the people who sign up as patrons actually take me up on this offer and we do it. But it's great. And it's, I've only had like maybe one person try to use this as an opportunity to sell me on their pet theories about the cosmos. Most of the time it's really cool conversations who, if I lived in the same city as these people, they would be my friends, right? Which is such a great experience. And that there's just like all these like-minded people out there around the world. So if you're a creator, and like, I know this feels like it's an impossible thing to do, figure out a way that you can talk to your fans on a regular basis. I've done 1,200 and something of these interviews at this point. I've been doing them for years and years and years. And I'm so glad that I do it. And I've never met anybody else that does this, and they should, because they're sort of, this is a chance to refill your joy of the work that you do. Beakley, I was enamored with Scavenger's Reign. Do you have any recommendations similar to that show? I'm currently watching your other recommendation for All Mankind and loving it. So the creators of Scavenger's Reign did another show called Common Side Effects, and it is also great. Not quite as great as Scavenger's Reign. It's essentially about this guy who discovers this mushroom that is a cure-all for everything, and how sort of the governments and the medical industrial complex is trying to keep it down, and it's great. It's great. Like, if you enjoyed Scavenger's Reign, Watch Common Side Effects. You'll get kind of the same vibe from it. It's not as weird and alien as it is. I mean, my current top 10 list is Pluribus. So if you haven't watched Pluribus yet, it's great. Alien Earth, For All Mankind, Scavenger's Reign. Man, why am I not able to quickly think of the things that I love? Love, Death, and Robots. So if you haven't watched Love, Death, and Robots on Netflix, I think you should watch that. I should really... I'll make my list. Oh my God, I'm so sorry. I'll let you know what my list is. Mr. A.J. Mitchell, how close do you think we are to dramatically extending the human lifetime? Not close enough. I would love to have my human lifetime dramatically increased. And how's that coming? I think that we could be on the cusp of a revolution across all of science, theoretically, with the rise of artificial intelligence. The things that were easy to do, like writing your college essays or programming, have been done. And as a person who kind of lives in the programming world, it's a very weird feeling to go from this thing is useless to this thing has some potential, but you have to watch it very carefully, to this thing just works. You task it with challenges and it comes back with code, and the code runs and it does what you need. Now, you hear all these horror stories about the code deleting people's hard drives and causing all kinds of damage. And for sure, but that is, that's giving a gun to a baby and having them walk around, right? So you got to be very, very careful about how you use this stuff. But it's astonishing that you can work with these tools to have them write code. Like this thing that's showing up, like you can't see the database that I'm running right now, but we just built it all internally using Claude Code. And I've got a bunch more ideas. Wait till you see the telescope streaming setup that I built. Like we literally made our own sea star with the telescope. It's amazing. It tracks, it finds objects, it sorts them by height, it integrates with a visual, with a map of the sky, it live stacks the pictures. It's incredible. And we just developed the whole thing. So anyway, I'm rabbit holing, but I'm just saying, like, that's what it feels like when this stuff falls under the capabilities of artificial intelligence. And it feels like the next step is then things like materials engineering and medical research are going to fall under the capability of the AI to at least assist and accelerate this stuff. And, I wouldn't consider myself to be a transhumanist, but maybe I am. I don't know. I don't think there's any reason why human beings can't have their lifespans extended. I don't think there's any reason why we should have to die. What a dumb thing. We should live forever, or at least live as long as we choose. So hopefully in my lifetime, we will get to a place where we can extend our lifespans as long as we choose. We're not there yet. People die, but it would be great if we could. What is the Miffed Spaceman? I've never even seen that. I don't even know what that is. Happy Butters Blast. Who is your favorite astrophysicist and why? Man, I don't have favorites. Like I talked to so many of them. So I'm going to go with John Mather. All right. Nobel Prize winner, John Mather, mind behind the James Webb Space Telescope is just like the nicest human being you've ever met. He's so nice, and he's so kind, and he's so generous with his time. He just sent me an email about their new Starshade project that we reported on Space Bites, and he's let me interview him like, I don't know, 2 or 3 times, and so it's just great. So I would say, he is both a brilliant mind behind one of the greatest telescopes that's ever been developed, and has a Nobel Prize, and is super humble and really nice. So there you go. There's my favorite astrophysicist. Tricky Mick, is it possible that the strange orbits of the dwarf planets in the outer solar system were caused by an ancient stellar flyby? It seems like it could also have affected those orbits. Yeah, this is a legitimate theory. It's been proposed that a rogue planet flying through the solar system could have caused the jostling of the could cause the jostling of the outer Kuiper belt and put the various dwarf planets into the positions that they're seen. There was a paper that we reported on, I feel like it was maybe 6 months ago, 9 months ago, that sort of did the math and found that you would need to have a rogue planet passing through at this velocity, at this distance, and that you could get the sort of the orbits of the Kuiper belt objects could be explained by that process. So it has absolutely been considered and is a perfectly feasible theory. And of course, the problem with that is then you can't then track the object down. It's gone, right? That it might have happened 1 billion years ago, and now you'll never know what happened. And so if we fail to find Planet 9 with Vera Rubin, then it's almost certain that that's what happened. That at some point in the last, few billion years, a rogue planet came relatively close to the solar system, caused passed through the Kuiper belt, and caused a disturbance to the objects in the area. Robert, do you think the disclosure hype is really about real aliens? No. I think that lots of people think that the disclosure hype is about real aliens, but there need to be real aliens to disclose. And, we have been waiting for decades. People have been saying that the government is hiding information about aliens for decades. And we got this big hype a couple of years ago. Was it like maybe 5 years ago? Where people, and kind of the same people who had been telling us that there was evidence of hidden aliens, had been saying this for years, and then they finally got they got a lot of attention. There was a NASA board put together to try and search for any evidence of UAPs. There was a military search, and there was, some examples of things that were declassified, and people went through them. People have been saying that there are, alien bodies and pieces of spacecraft in storage, and yet these have never been delivered. It's been made illegal in the United States to hide information about these aliens. Didn't Trump just say that he was going to release the information? Like, it's not there. Like, that we are waiting, and until somebody actually delivers the goods and says, okay, here, fine, here's your alien, scientists, have at it, then we can kind of safely assume that there's nothing there. It's a nothing burger. There are plenty of things that are unknown, that are unidentified, but it doesn't mean that they're aliens. It just means that we just don't have an explanation for them yet. But there can be perfectly reasonable, rational explanations for every single thing that's ever been seen. We just don't necessarily have it right now. But you shouldn't jump to aliens as the answer. So, and it's funny, like, I don't see the people getting angry at me in the chat anymore about how I'm denying their belief in aliens and UAPs and all of that. Like, they just moved on. They just moved on to the next thing that they're excited about, and they're no longer even in my chat. They don't post comment. They're bored, and that's because there was never anything there to begin with, except for people trying to sell them things. And once you've bought all of the things, you bought all the courses, you've attended, watched all the TV shows, bought the merch, and there's still no disclosure, after a while, you kind of move on to whatever is the next thing. So, nope, I am unconvinced that anything will ever be revealed by any of this. But I can't wait to be wrong. Like, boy, it will be awesome. And, again, people don't believe that I believe this, which is that I would love nothing more than to find out that we are not alone in the universe. That's my greatest dream. Right? I want to know if we are alone in the universe. But I want to know for sure. I want to have evidence. I don't want to have a hunch. I don't want people to tell me they heard from a guy that there's aliens in the universe. I want the evidence to be irrefutable so that I can move forward with that knowledge. Moon Trustee, have you ever considered moving out of Vancouver Island since it's overcast 99% of the year? Oh, tell me about it, right? Like, of course, I get this telescope operational in 2-hour chunks that I get some clear skies. Yeah, it's been rough. I mean, the long-term idea is for me to book a space at a place like Starfront, right down in Texas, where they have clear skies every single night and automated systems to open up the telescope domes. You could just operate from there. Like, eventually I'm sure that I will send my mount and scope and telescope down to or camera down to Starfront and then use their system down there, or come up with some kind of collaboration with them so that I can have a twin of the system that I've got set up. They can, we'll figure something out. So no, instead of me moving off Vancouver Island, I'll just move my telescope off of Vancouver Island. Jonathan, is Vera Rubin data purged of military spacecraft? Yes. So it's a collaboration between the National Science Foundation and the Department of Energy. And so there's this data pipeline. The data comes off Vera Rubin, goes to the US. They remove the mentions of the various military classified satellites, the various surveillance satellites, and then they pass along the data. So yes, that's the deal. That's the price that you had to pay. Paige Potter, do you think we're closer to discovering alien microbes or alien megastructures? It's an interesting question. So on the alien microbes idea, this is the idea of biosignatures, that you would measure the atmosphere of an exoplanet and then you would detect the presence of, methane or ozone or oxygen or some interplay between water vapor and methane and ozone and oxygen in the atmosphere of this planet. And that would tell you that there's life there. There's seasonal cycles. You're seeing the rise and the fall of the methane and the carbon dioxide in the atmosphere, and that tells you that there's life involved. You wouldn't get any more information. You'd be like, there's life on that planet, and that's all we know. Yes or no, there's life in the universe. While a technosignature is very unambiguous. Like, for sure that there is no way that a natural process can create a triangle-shaped space station that is orbiting around a star. And you would even start to learn about some of the capabilities of that civilization based on the kinds of things that you're seeing, or them sending you a message via radio. That would be incredible, right? So on the one hand, it's probably easier technologically, and there's probably more examples of bacterial life on planets around the Milky Way. On the other hand, it's going to be very ambiguous. You're not sure, right? It's inconclusive. You don't know for sure that you've actually detected the presence of aliens on that world. But if you have the techno signature, then the evidence is unambiguous. You know for certain that you have detected the presence of an alien civilization. And in fact, you can maybe even communicate with them or learn information about them. So both are the way. Like, you don't want to choose. So which one do I think we're going to find first? I apologize for the big long delay. Okay, so in my heart, I think the answer is neither. We're going to find neither first. That we won't find either evidence of biology going on in atmospheres, nor will we detect the presence of alien megastructures. But if I had to pick one, probably the biology, probably the bacteria. Like, I think we would probably detect the presence of some kind of biological process that is changing the atmosphere of a world or giving off some kind of waste gas that is a clear indication of a biosignature before we detect some message from another civilization. Probably. Josh Miller, who'd you rather interview, Rodney McKay or Daniel Jackson? Oh, Daniel Jackson. He seems way nicer. Rodney McKay's a jerk. So yeah. Moon Trustee, how do you feel about BC implementing year-round daylight savings time instead of switching back and forth? So I don't know if you watched the live stream. Last week, in kind of real time, I just had the horrible realization of what this really meant. So on the one hand, I'm really excited that we are no longer going to be switching our clocks back and forth. Although at this point, all of the clocks in my life do this automatically, except for the one in my car. Like, the one on the radio in my car does not switch automatically. And so the only evidence that I get that we have switched time zones is that my clock times are wrong in my car. And I was like, yeah, we're living large at this point. Like, suckers, you have to have to deal with the moving forward an hour and backwards an hour, dummies. And then last week I realized that we still have to think about it because we have to interact with the rest of Canada and the US and the world. And so now I have to think about, for example, if I'm going to schedule a recording of Astronomy Cast with Pamela, I have to go, okay, wait, is she an hour ahead of me or is she 2 hours ahead? Because normally she's just 2 hours ahead of me. But now sometimes she'll be 1 hour ahead of me. Another time she'll be 2 hours ahead of me. And I will have to mentally keep in mind everybody's time zones and whether I have to add 1 or 2 or 3 to their time zone. And like, I know, like, you Europeans, like, this is your life, right? Like, we are already completely insensitive to your standard time. And, you know, sometimes you're +8 and sometimes you're +9 and sometimes you're +10. And, oh, there you go. And Type Furls is saying, welcome to my pain. I'm from Saskatchewan. So, yeah. This is, so now I take it all back. Like, either we do this together, an international collaboration, the whole planet, we work together to abolish daylight savings time, or we all stick on daylight savings time together. But this, some people switching back and forth and other people not, is madness. And I'm already envisioning how much I'm going to hate this, and it hasn't even happened yet. That we had the last switchover a couple of weeks ago, but I haven't had the next switch over where now I have to run this mental model of everybody else's time zone. So I take it back. This is terrible. I regret it. I want us to go back. I need us to ditch this permanent time zone. Take us back, please, 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 please. Yeah, Rodney McColoney. Isn't Newfoundland on a half-hour time distance? Yeah, those poor people in Newfoundland. Oh man, that like when we were growing up in Canada, Canadian television would say something like, the Star Trek. It's on at 8 p.m. 8 p.m. 9 p.m. Mountain Time. And 9:30 in Newfoundland. You just be like, what? They're always living a half hour off? That's terrible. It's brutal. Oh, poor people in Newfoundland. Oh. The other Casper, if the DOE removes the US satellites, that means that everyone else's satellites are in the data, right? Are amateur satellite trackers tapping into the data pipeline? Yeah, I mean, yeah, they'll be there. I mean, if they are in the Earth's shadow, sorry, if they're not in the Earth's shadow. So keep in mind that you can only see a satellite if it's being illuminated by the sun. And so typically you only see satellites shortly after the sun sets if the satellites are low, or a while after the sun sets if the satellite altitude is very high. But like satellite trails are not a thing that the people using Vera Rubin are looking forward to. I mean, even for me, I built into the algorithm that does the photo stacking an option if I want to just remove the satellite trails. So it will throw out frames that have satellite trails in them. So I've got that control at this point, but they suck. So, but there are lots of amateur, or not amateur, but commercial operations that do tracking for everything in the sky, like down to pieces of space junk that are a couple of centimeters across. So all of the satellites, their positions are known, and people can track them. I mean, you can go to, was it Heaven and Earth? There's like a bunch of satellite tracking websites you can go to find out, like, what was that satellite that just went overhead, and you can track it. Where are we at? Whoa. All right, let me go back earlier. Ed Skeptic, did life evolve from a virus? I mean, we don't know, but viruses and life went hand in hand. So virus would need something to infect. So probably not. But viruses probably transmit bacteria, or sort of transmit DNA between species. That's one thought. Go Lord, if an amateur uses Vera Rubin data to find Planet 9, do they get to name it? No. So if you, and so this is something that I'm not entirely clear upon, which is that if you use Vera Rubin to find an asteroid, you probably get to name it. You get to name it after whatever you want. I mean, as long as it is appropriate. If you find a comet, the comet will probably be named after Vera Rubin, but maybe you will get your name in it as well. But if you find Planet 9, that will be named by the International Astronomical Union. However, you will get a vote. So when you had like Eris, which was named by Mike Brown, it was ratified by the IAU, but he had proposed the name. And so you could do the same thing. You can propose the name, and then the IAU will ratify that name if it's not, Dwarfy McDwarf face. Giohondo, what media content can we expect from the Dragonfly mission on Titan? Hopefully video. It won't be video because just the data transmission rates from Titan are so low. So it'll be pictures, but they will be amazing pictures. I mean, we have one set of pictures from the surface of Titan, which was taken by the Huygens probe when the Cassini mission arrived at Saturn. Dropped the Huygens probe. You got these these images of it sort of descending down through the atmosphere, and then this image from the surface. And then that's it. That's all we got. And so now we're going to have just day after day after day of pictures of this thing flying around. And kind of the same way you have pictures of Mars from Curiosity and Perseverance. So imagine that. And then people will absolutely be able to stitch them together into videos, but they won't be like 4K high def streaming video. It'll be more like stitched together images, like a slideshow. Just looking for questions. See what I've already covered. Joseph William Pillabello. If we include Pluto, where do you draw the line? So, like one of the issues that I think a lot of people, when we say that Pluto is not a planet, and this other planet that's out there is Planet 9, people go, well, Pluto is already Planet 9. And then people will pick their side, and then they'll have fights. And the reality is that we're never going back to Pluto as the 9th planet, or there only being 9 planets in the solar system. And that was because of the discovery of Eris, right? Eris is an object that is roughly the size of Pluto. And so if Pluto is a planet, doesn't Eris get to be a planet? And you're like, well, probably, yes. Okay, we got 10 planets. Well, wait a minute. Well, Ceres is kind of the same size, and it's in the asteroid belt. It's closer. Doesn't it get to be a planet? Oh, yeah, probably. Okay, great. So now you add Ceres. Well, what about Haumea? What about Makemake? What about, there are all of these objects. And so you could say, well, that there are 100 planets in the solar system if you consider the big moons. There are moons as big as planets. Ganymede, Titan, they're gigantic. So it just doesn't make sense to draw this line and say, these are planets, those are not. Or to even, I think, get emotional about it. For me, I don't care. Like, Pluto is amazing, and it is a thing, and we have taken close-up pictures of it and its moon, Charon, and it's incredible. And I don't think it makes it any less special or more special whether it's designated as a planet or not. And it's sort of like a pointless argument because, are you going to make kids learn the 37 planets of the solar system, right? Because it could very well be that Vera Rubin will turn up another dozen objects that are the size of Pluto or larger in the Kuiper Belt. What do you do then? So, yeah, don't worry about it. Frosty Winnipeg. I've heard people say 9 is Neptune size, and I'm thinking, wouldn't a gas giant be easier to spot than a rocky planet? Yeah, I mean, so if Planet 9 could be the size of Neptune, but farther out, maybe like 500 astronomical units more, 1,000, or it could be the size of Earth, or Mars maybe, but be maybe 200 astronomical units out. It's just that whatever it is too faint for our current telescopes to have spotted it. The survey telescopes, like the best survey telescope that we had was WISE, which was this infrared survey that was done of the entire sky. It was this mission that was launched back, like 2013. Maybe that's when it even ended. Anyway, like well over a decade ago, the WISE mission did this survey of the entire sky. And one of the things it was looking for was large planets in the outer solar system. It was looking for Jupiters. It was looking for gas giants out there, and it ruled them out. But you get smaller objects could still be out there. So there's kind of an upper limit to how big Planet 9 can be, and that's kind of like Neptune sized. And so you can spot a larger object farther or a smaller object closer. Tricky Mick, while you do interviews to new patron members, do you ever do any larger meet and greets when you travel to different places? I would have signed up when you were in Tokyo. Well, good news, I'm coming back to Tokyo in May, so I'll maybe make a mention that I'm going to be in Tokyo. So we have tried to do events in the past through Astronomy Cast. For our 500th episode, we did a meet and greet. We did a party at Edwardsville, which is just outside of St. Louis, which is where Pamela lives. And we had like maybe 15 people show up. So I think it would be cool to let people know when I'm going to be in their town, and then like, let's all meet at this bar and we'll hang out for a couple of hours. But trying to organize things that are larger, more complicated, more moving parts just is both like a ton of work, and not a lot of people find out about it just because it's really hard to kind of reach out and communicate with everybody. I have been asking the new patrons where they live, and so then I can send a message out to everybody who's in, Seattle, if I'm going to be in Seattle or something like that. But it's just, again, we kind of like just don't have the infrastructure for that kind of planning. Like, you need planning events is a whole other world of thing to do, and you kind of can't half-ass it. And that's generally the way I do that kind of thing, is like last minute go, oh yeah, by the way, I'm in Tokyo, anyone here? And nobody shows up. So but yeah, I'll let you know. Yeah, we're going to be back in Japan in May. This time I'm taking my wife. Sorry, this is great. There's just a conversation between Ed and Thomas Muir about Ed Skeptic and Thomas Muir about with an alien, a different type of DNA infect us. And Thomas Muir is saying, Ed is actually asking, can we eat aliens? Which I think is exactly right. There's no reason to believe that we would be able to eat aliens or that they would be able to infect us. Like, we would have evolved in completely different timelines. We would have totally different, even if we even have DNA, proteins would be very different. So yeah, I doubt we would be able to eat them. And I doubt very much that they would be able to infect one another, even breathe the same atmosphere. All right. I think we've reached the end of this week's episode. So thank you, everyone, for hanging out with me today. Thanks to ZapFan, who you can remove the extension from your Chrome now, ZapFan. I think we're safe. But thank you so much for all of your help. I really appreciate it. 5 interviews coming later on this week. That'll keep me busy. What have we got tomorrow? New QA tomorrow. Interview Wednesday. Another QA on Thursday. Space Bites on Friday. And the new Patrons QA is done recording. It was another monster. And so we will be releasing that maybe tomorrow. We'll see. Yeah. So we'll see all of you next week. Thanks, everyone. Where's the button? There it is.